guys, next what we're going to look at is adding and subtracting expressions as far as dealing with polynomials, okay, so with rational expressions. Couple things. I do want to bring attention to these quality questions, and they are, why do you need a common denominator when adding and subtracting, but not when you're multiplying or dividing fractions, okay? So why do you need a common denominator when you're adding and subtracting? And then, how are the basic operations of rational functions similar to those of basic functions? Okay, so let's go ahead and begin. So adding and subtraction or subtracting rational expressions. First of all, let's review. Let's review some fifth grade. So multiplying, just real quick, we don't need common denominators. We multiply straight across and we get 5 times 1 and 2 times 2. We get this, okay? If we were dividing, we don't need common denominators. We just have to keep, change, flip. So we keep this, we change it to multiplication, and we flip this to be 2 over 5. And yes, from here, you've been taught to go ahead and multiply it straight out to get 2 over 10. But I say, before you multiply straight across, always see if you can cancel, reduce anything from the top and the bottom. And if I can, well then all what's left up top is 1 and 5 on the bottom. So it's already in reduced form because you canceled early. You always want to cancel as early as you can. In this particular instance, that's exactly where it would occur. Now, we don't need common denominators. But if we're adding or subtracting fractions, we need common denominators, okay? So let's go ahead and look at the denominators that we have right now. We have 2 and 2, so they are common. So then we can combine this as one big fraction with that denominator of 2, okay? And what we're able to do is combine the top, which was the 1, with the subtracting the 5, and we get a negative 4 over 2, which if you wanted to reduce it all the way, you could say negative 4 divided by 2 is a negative 2 as your final answer. Okay, so that's just quick review. Now, this one, we don't have common denominators, okay? So we first have to get these denominators to be common, again, before we add or subtract fractions. So let's do a form of 1. We've been canceling forms of 1 like x over x canceled to 1, x squared over x squared, so on and so forth, canceled to 1. All these that are the same are going to cancel to 1. Just FYI, the only two that do not cancel to 1 are 0 over 0 and infinity over infinity. Okay, those do not equal 1, and you'll learn that in calculus at a later time. But nonetheless, those do not equal 1. They don't cancel like this to forms of 1. Okay, so like we canceled forms of 1, we're not going to create forms of 1. I'm going to create a form of 1, which is 2 over 2, that I'm going to multiply with just this piece here and just this piece here. So it becomes 2 over 6 to now I have the common denominator of 6. So I'm going to write that as one fraction. And now it's just 2 plus 5, which is 7, so that I get 7/6. And I can leave it as an improper fraction if I want. Okay, so this 7/6 is my answer. Now let's move on and let's go and subtract. Okay, so now we don't have common denominators. And now I can't do it as simple as I did this one on number 2. Notice that I only looked at altering one of the fractions. But here on number 3, I can't do that because I can't multiply 1 to become the other. I can't multiply something by 5 to get 7 as easily as I did before. Okay, so what we're going to do is we're going to multiply this by a 7 over 7 and this one by a 5 over a 5, because look at this. Now we have a 35 here and we have a 35 here. Up here, multiplying these numerators, we would have 21 over 35. We would have 20 over 35. And now when we subtract it, it has a common denominator of this 35. When you have a common denominator, then you can combine those numerator pieces and say 21 minus 20, which would give me 1 over 35. Okay, so 1 over 35 is going to be the answer for that one. Now, real quick, what I want to do is quickly show you a semi-shortcut, if you will, that when you have fractions, whether they look like this or whether they look like number twos, 1/3 plus 5/6. Okay, so 1/3 plus 5/6. Since we're trying to get this common denominator piece, a shortcut that you could use is that you can multiply diagonally up and diagonally up here. So 7 times 3 is 21. 5 times 4 is 20. We're going to be subtracting this because that's what the problem is saying here. So we're going to put subtraction here in the numerator. And then now just think, what does 5 times 7 become? Well, it becomes the 35. And quickly we go to where we were over here with more work. Okay, so this is a fast shortcut so that we can quickly get to our final answer. And it works here too. If I multiply diagonally, 6 times 1 is 6. 3 times 5 is 15. I'm adding, and it's going to be over the product of what these two pieces are, which is 18. Okay, so I get 21 over 18. Now the difference here is we reduced early back here. Okay, as far as our piece is concerned, we could reduce early. When you do it like this shortcut, you might have to look here and say, okay, now what can I reduce by? So if I reduce this by 3, the top will become 7, and reduce the bottom by 3, the bottom becomes 6. And that's how you got that 7/6. So it is a shortcut, but make sure that you do, in fact, reduce there at the end. All right, so now let's look at number 4. 4 is a little bit different. It has almost like two problems inside of one division. It's like what we were just doing on 1 through 3, do it for that one, and do it for this one, and then reduce by canceling and simplifying there at the end and see what you get. Okay, so let's treat this as 3 problems. I'm going to first look at 2/3 over 4/5, and I'm going to use that little shortcut that I just showed you, 10, 12, we are adding, and it's over the product of what this and this are, so 15. So we have 22 over 15 is this numerator piece right here. Let me highlight it so you can kind of color coordinate it. Okay, so again, we're treating this like 3 problems. Let's do the bottom one. We have 5/3 minus 2, which is understood as over 2 over 1. So 1 and 5 will give us 5 because we're multiplying. 3 and 2 gives us 6. We are subtracting, and it's going to be over the product, the multiplication of 3 and 1. So that we get, like we got up here 22/15, here we're going to get a negative 1/3. And this was our denominator piece. So now all we have to do is treat it as a third problem by saying 22 over 15 divided by negative 1/3. Now this looks difficult. It looks difficult, but we're going to simplify this. Because a fraction over a fraction already looks difficult, we're going to go back to 5th grade and we're going to rewrite this. We're going to say 22/15 divided by negative 1/3. This looks much, much easier to work with because of keep, change, and then flip. So negative 3 over 1 is the flip. And if you wanted to put the negative in the bottom, it's still the same thing. It's going to be a negative 3 anyway. Okay? Okay, so looking at this, now all I have to do is just multiply straight across or reduce as early as I can, which I'm going to do right now. I'm going to reduce this as early as I can. So this 15, I'm really looking at a 5 and a 3. And this 22, I'm really looking at a 2 and an 11. And now I want to see what can I reduce from the top. Well, the top and bottom that match up. There's a 3 and 3. So you know that's your factor. That's going to go away. So does anything else cancel reduce to a form of 1? No. I have left over. The leftover scraps that I have are 2, 11, and negative 1. On the bottom, I have a 5 and a 1. So let's multiply the numerator first. So I have a negative 22, because we're going to distribute or multiply all the pieces that are left over. And then on the bottom, we have this 5 and this understood 1. So we get 5. So this is the most reduced simplified form of what this piece is. Okay, let's keep going. Our next example, we're going to start looking at binomials. We're going to look at all these x's, but we're still going to do the same kind of fundamental properties that we were doing over here with 5th grade review. Okay, so let's go ahead and look at this. What is the sum? That means we're adding, and we're going to add this with this, and then we're going to give it its simplest form, and then at the very end, state the restrictions. Okay, so let's first set up our problem. We have x plus 1 over x minus 1, and we're going to add with a negative 2 over x squared minus x. Now, when you are adding, we just did review problems, fractions, you need a common denominator. And right now, these are not common. So what we need to do is we need to create a common denominator to see what do we have to multiply one of the fractions by. Okay, so first of all, first step is that you should factor so that you can visually see which ones that you're going to be doing to which fraction, if you will. Let's GCF an x out right here. And now we see in the denominator of this first one, I have x minus 1. To where if I wanted to, I could put parentheses here. And you can see, ooh, this looks pretty close to what this is. The only thing that this first fraction is missing is this x that this other fraction has. So what we're going to do is we're going to multiply by a form of 1, which is x over x. So that way now we have the entire denominator is equal to this other denominator. What we just did is what we were doing back here with these examples. We were trying to, and then on number 2, we were trying to match up, or we are trying to match up the denominator, which is now matched. Okay? So because the denominators are matched, now we can add these two together. But here's the trick, or here's the catch. The extra thing that we have to do is we have to simplify the numerators and then add them up together. So let's simplify this first one. X would distribute, and I would get x squared plus x. This negative 2, nothing happened there. And what we're going to do is we're going to add this piece with that piece. All I did was simplify the numerators and then add them as separate pieces. Now, you see a lot of parentheses right now that I just did. The reason why I did these parentheses is I want you to see that this came from the first fraction and this came from the second one. But also, if this was subtraction, it would distribute across this parentheses if there was more than one term here. And this is the most common mistake that even all the way to calculus people make. It's when you're distributing a negative across a polynomial, like something that has 2 or 3 terms. Okay? So what we want to do is, since this is just a monomial, it's not going to matter particularly on this one. But we want to make sure that we understand that we're adding this negative. So it's like just subtraction, okay? So first of all, let me go ahead and simplify that. That would be x squared plus x minus 2, okay? And now let's look at the denominator. It was common here and it was common here. And just like the other examples that we worked with, we're going to write it one time. Please do not try to add denominators together. It's only the numerator piece that adds. And that's only when these have a common denominator. Okay? So this would be x and x minus 1. And now we're here as far as almost finished with our answer. I will factor one last time and see, ooh, this is x plus 2 and x minus 1. The bottom remained my common denominator piece of x times x minus 1. And check this out. I had one more cancellation that could happen between this multiplication and this multiplication piece. Remember, the entire parentheses cancels, and whatever is left over would be x plus 2 over x. This right here is our most simplified form. Now listen, I canceled right here and here because multiplication existed between those pieces. I cannot cancel those x's right here because addition exists between the pieces. If addition or subtraction, reminder, you can only reduce between multiplicative pieces. Okay, so this right here is my simplest form. Now let's talk about restrictions. Okay, so the restrictions that I'm going to have are going to come from not only the final answer by looking at the final answer before it was reduced, but also before and even during the problem. Okay, so let's go back to here when I first had x plus 1 over x minus 1 plus a negative 2 over a factored x minus 1. Here is really where I'm going to see all of my restricted pieces. I know x cannot equal 1 here because it would make this denominator 0. Just the same here. X cannot equal 1 because it would make this 0, which would make the whole fraction here equal to 0. Okay? So x cannot equal 1. Let's go ahead and write that. X cannot equal 1. And then this one right here, x cannot equal 0. These are my restrictions. And because this was like the original piece, as we went through the problem all throughout, we're still going to have these kind of overlapped, if you will. This x cannot equal 1 appeared here again. It appeared here. And this x cannot equal 0 appeared here, here, and here. So nonetheless, we took care of all of the restrictions. Okay, so let's keep going. Let me make sure I'm not missing anything. All right. So our next one is going to be, what is the sum of this in simplest form? And then we're going to do the restrictions. This is very similar to this one, only there's a little bit more factoring. Okay. So let's first start off by factoring all the pieces. So 2x minus 1, there's no GCF there, but I can have an x minus 2 and an x minus 3 is the factored form of that denominator there. So now this one, there's nothing to factor. Okay, and we're looking at the sum. So we're going to be adding these two fractions. And now I want to see, what does the common denominator look like? Well, these are the same. But this first fraction is missing an x minus 2 here. So I'm going to create a form of 1. Can't just do it on the bottom. I have to do it on the bottom and the top because that's a form of 1. And again, I'm not canceling right here. I'm creating it so that I can have common denominators. Okay? So now my common denominator between both of these fractions is x minus 2 and x minus 1. That's my common denominator. Okay? So now let's simplify this. So we'll distribute that x across both terms. So we have x squared minus 2x. And then we have the rest of this is going to be added. Now look, I'm going to put, this is my first fraction, this is my second fraction, and I'm going to add them together. The reason why I chose that is, again, sometimes this will be subtraction, and this parentheses would then distribute. So to get in good practice and good habit, that's why I'm showing it that way. Because this is addition, nothing's going to change. The top will become x squared minus 2x plus 2x minus 1. And the bottom, I am not ever going to distribute this until I'm ready for my final answer. Don't distribute your denominator until you're ready for your final answer. And you'll see that what that looks like here in just a bit. So now let's simplify. We have an additive form of 0. These cancel to 0. So real quick, just FYI, this would cancel to 1 because it's multiplication and division. They just cancel. But if I'm adding opposites, they cancel to a form of 0, which could look like this, or adding something that looks like this. So addition cancellations cancel to forms of 0. Multiplication and division cancellations cancel to a form of 1. Very, very important. Here is a cancellation of 0. So I have x squared minus 1, which is a difference of squares, over that x minus 2, x minus 1. So if I factor the top, let's factor this top, x plus 1, x minus 1. And my common denominator is still x minus 2, x minus 1. Check this out. Now I have this entire binomial canceled with this one because multiplication exists right there. Again, you're only canceling those chunks of multiplication. And what's left was going to be just this piece that nothing else can cancel reduce. Nothing else can cancel reduce. So now I will fully simplify both top and bottom to become x plus 1 over x minus 2. Now, restrictions. I can see from the original problem, x cannot equal 2. I will write that immediately. But then I want to go back and look at the very, very earlier stages and see when the denominator would be 0. Okay, so let's look at this one right here. Well, we have 2 and 1. So I'm going to have to say x cannot equal 1 as well. But if I went even earlier than that, and even went to the original one, I know x cannot equal 1. And whatever this ended up becoming, whatever this x is, well, this we saw right here. It cannot equal 2. Let me highlight it in a different color, or 1. So 2 and 1 are right here. 1 is up here. So it just still remained as 2 and 1. 2 and 1 were my only restrictions. So my full answer is going to be right here.